It's 3:52 in the PM. It's after school and it's Halloween, so I know what you guys are thinking. Let's do some geometry. I know that's what I'm thinking. So let's get rolling on this. This is totally the homework 1 set, so the very first worksheet you were given on Tuesday. And I'm just going to go through them question by question. So this will be posted. If you have questions, please post it under the video. I'll try to address them. Otherwise, let's rock and roll. So in this diagram below, the following congruency and the congruency statement also listed. Lists all pairs of corresponding congruent parts. And really this question is really centered around, can you read this? Can you understand what this actually means? Because if you can, you're totally golden. Now this is not a triangle, hence there is no triangular symbol. We're given a set of 4 points indicating a plane or a plane figure. In this case, we're dealing with these parallelogram looking things. What's really important to note when we try to kind of emphasize in class is that if you're looking at MATH, if you're looking in this direction, you should be looking at the other shape in the same exact way. So CKRO, CKRO, and then back to C. So in other words, this is kind of where I'm quote-unquote starting. This is where I'm kind of quote-unquote starting. And that's really going to help us make this congruency list, because if you weren't paying attention to this name, you may think that MA corresponds to RO, and that's simply not the case. What we have to look at is right here. Let me see if I can pull Mr. Magic Pen. Where are you? There you are. So we really have to look at is a pair at a time, because 2 points make a line segment. If MA is listed first, that means it correspondingly is congruent to CK listed first on this side. So MA corresponding congruent to CK. AT corresponding and congruent to KR. TH corresponding congruent to RO. And of course then HM correspondingly congruent to OC. So the names tell us everything. In fact, you can do this problem without looking at the picture at all. It might not be a bad idea. I'm going to annotate the picture, which means drawing the picture as I'm kind of making my congruence list to try to kind of drive this point home. Alright, so let's get into it. Let's start right here just with the list of line segments. So the first one, again, the first 2 letters, MA, is going to be correspondingly congruent to the first 2 letters here, CK. So again, this is going to incur some like rotation, some flipping, some moving around, some other rigid transformations. And again, don't get fooled into thinking just because the picture looks similar that MA is correspondingly congruent to RO. That is simply not the case. So making our congruency list, our first one will be MA is corresponding and congruent to CK. Moving to our next set of letters, I have AT is correspondingly congruent to KR. So AT, KR. Okay. And again, it's about the congruency statement. It's not about the picture. The picture will fool you if you're not careful. So here you have TH and RO. Okay. And then finally last, and we should check it, we shouldn't just kind of say, well, that's the last one, it's obvious, we should always check it against our congruency statement. We have MH and we have CO, and that seems to be okay. So we have MH and we have CO. Alright, so that's our 4 sets of sides. Of course, we're not done. We have to deal with the angles as well. Instead of kind of using the 3-letter naming convention, I'm going to pull a trick that we pulled in proofs, and I'm actually going to go ahead and just number my angles. Okay. And I numbered them just what made sense to me, not necessarily the ones that are corresponding and congruent. In fact, we should be really careful here. So if we're looking up at the diagram, again, we could look at the kind of congruency statement here, and that would be totally fine. I'm going to use a diagram, though. If I'm looking at this angle 1, right, what I'm going to notice it's kind of between the one with 1 tick mark and the one with 4. So I would claim, come on, pen, what you doing? Oh, my pen's freaking out. Technical difficulties. Okay, so anyway, whoa, there she goes. So this angle 1 is trapped between the line with 1 tick mark and the one with 4. So if I go to mark this, I should be able to find this pair over here. Again, between the one with 1 tick mark and the one with 4. So it looks like 1 is going to be congruent to 7, correspondingly congruent to 7. Okay? And we'll use that same kind of methodology for the rest. So if I'm looking at angle 2, it's between the line segments with 1 tick mark and 2 tick marks. So between 1 tick mark and 2 tick marks, that's going to be angle 8. So angle 2 congruent to angle 8. Okay. Angle 3 will be between the ones with 2 tick marks and 3 tick marks. So 2 and 3, that will afford me angle 5. And of course, the last one should just be angle 4 and angle 6. Okay. Now that can be told from the congruency statement as well. For example, if I look at the angle MAT, that should be the same as CKR, with A being in the middle of my series in the second position, so we're looking for the second position vertice over here as well. I mean, that's another way to look at it. I mean, it just was easier to go back to the diagram once I had the sides marked, which is kind of the importance of marking sides and angles in your diagram. But again, yeah, that's just kind of your overview on how to make a congruency list. Now, if you were looking at this and it is Thursday or Friday, well, then you already have some good knowledge of how we're going to actually use this for proof. In fact, the only difference between this congruency list and an actual proof is that proof would actually have justifications out here. These are given, these are whatever, these are vertical, these are using some derivation of the Pythagorean theorem. Point being, this is very close to proof. Alright, let's look at question 2. So, is it true that ABD and CBD are congruent? List all pairs of corresponding congruent parts and justify why each pair is congruent. So the first thing to determine is actually if they are going to be congruent, if we have enough information here. Now, this is not a proof, so big warning, this is not the proofs you're writing on Wednesday if you're looking at this on another day. What we're doing here is just have some kind of reason why these should all be the same in congruent pairs of corresponding parts. So right now I see this set right here, which are indeed congruent. I see a set of angles that are congruent. I see a set up here that are congruent as well. And then I see the rights. The sides I don't see are the one in the middle. Now that, if you haven't picked up on this trick, is a reflexive. It's a shared side. So by the reflexive property, those are going to be congruent to, that's going to be congruent to itself. And this last set should be as well, and it's going to be by some form of the Pythagorean theorem. So again, we're not trying to write a proof here, and you're not going to see a proof. What we are going to see is kind of a like a pre-proof, a plan for a proof. So if I know I'm going to prove two triangles congruent, or if I have any hope of doing so, I need to prove a bunch of angle sets and a bunch of side sets. So I have angle 1, first set of angles, second set of angles, third set of angles, first set of sides, second set of sides, third set of sides. And you saw this today. Oh, okay. So, yeah, we're just going to look at the pairs of angles, pairs of sides. So, again, I'm going to use that kind of proof convention where I'm going to name these by something else, so I don't have to use, like, the 3 letters at a time convention. I mean, I don't have anything personally against it. I just think it gets really sloppy when you're trying to explain something. So let's go pairs of angles. We'll start with 1 and 4. So the guy right here and the guy right here. The ones that occur at A and C. Not angles A and C, as you guys have totally seen me get on people's cases, but the angles that occur there. So we definitely have angle 1 congruent to angle 4. If we're going to supply a reason here, it's going to be given. Okay. Looking at second pair of angles, we're looking up here at the one at the vertice B. It looks like angle 3 can be congruent to angle 6. And that's going to be given as well. Angle pair 3 is more interesting. They are going to be congruent. If you look carefully, they're both marked to be right angles. Because they're right angles, they have measures of 90 degrees. 90 degrees make them the same measurement, and of course at the same measurement they're going to be congruent. And that's what we're going to try to capture here. Now, if it was a full proof like the ones you were asked to write on Wednesday, I demand all those steps kind of separately shown. But since this is not a proof and we're just kind of explaining and justifying, I'm just going to put here given as right angles. Okay. Now, again, please don't have selective hearing. This is not a proof. If this was a proof, I demand to see all those kind of right angles to 90 degrees to equal measures to congruency kind of listed out. But since this isn't proof and we're just explaining, simply saying they're given as right angles, that should be good enough. That's the conception or the idea behind it. Looking at the sides, we have some givens. We have AD going to be congruent to DC. That's going to be the ones at the bottom. We have this one we have this one in the middle is BD, congruent to BD. That's going to be reflexive. Which leaves us just side 3. Now, the big idea here, and if you remember Wednesday's warm-up, we talked about this quite a bit, is these are right triangles. If these are right triangles and two sets of the sides are the same, well then certainly the last side should be 2. So we can certainly claim that AB is congruent to BC. And again, the big idea here is a Pythagorean theorem. Hey, that's a big idea behind it. If this was actually a proof and not just kind of like an explanation or a proof light, I would demand that you kind of show that all in steps. But again, this isn't a proof. This is not a proof. That's my disclaimer. Not a proof. So this is going to be good enough. So we have all the parts listed. We have justifications for each part. You should maybe in the back of your head be thinking, man, that was a lot of work. That's a lot of steps. Can we shortcut any of it? That's what we'll be talking about on Thursday. Alright, so here's number 3. In this figure, which triangle is congruent to triangle ABC? So we have A, B, C. So A traveling over to B and then down to C, and then of course back over to A. So we're going to be trying to follow a similar path. This question is really all about, do you recognize that the order matters when you're naming these things? So A, 9 centimeters over to B, down to 5 centimeters. So we're going to do the same thing here. We're going to travel the 9 centimeter path, turn go on the 5 centimeter path, and then travel back down to C. Okay, so we're going from C to D to A back to C. So CDA, CDA, there it is, CDA. That's going to be my answer for part 3. So again, this one is all about the order mattering. If in the given triangle we start at A, travel to B, then down to C, which is what's given here, we need to follow the same path along the 9, down the 5, and then back up the middle. Along the 9, back up the 5, then down the middle. Right? So that's question 3. Let's go question 4. Okay, question 4. This triangle is equilateral. What is a coordinate of vertex A? Well, vertex A is given to be a variable xy, but the important thing here is that we have an equilateral triangle, meaning all 3 sides are the same. This is extremely significant because we're going to use this fact to actually coordinate A. So I'm going to blow this up because this demands a little more space than we're used to. So what we have to maybe first do is think about, well, if I'm looking at this length along the bottom, the one that we actually have a coordinate for at B, how long would you call this length? Well, hopefully you're seeing that if the x's start at 0 and then at 2a, the distance here to here would be 2a. Likewise, this would be 2a, and so would this. Now, that doesn't actually help us because we're looking at right down the middle of this, we're looking at this coordinate, that a, but one thing we should notice, I kind of stumbled my words, is that if this is equilateral, then this should be exactly in the middle between C and B. That's, again, extremely significant because if the distance between C and B is 2a, then the distance between C and then the midpoint should be exactly half. In other words, exactly a. So the x-coordinate is a. Now you're saying, well, Mr. Collins doesn't help us because he asked us to find the y-coordinate, but that's kind of thinking that is going to be involved. Like, we're going to take this distance and kind of mess with it. So this distance here is marked to be a. To find the y-coordinate, we have to realize it's really paramount to like finding this middle length right here, the one of the I just drew the arrow. If I can find this length, that's going to be the same as finding the y-coordinate here. This is really good news because this will be a right triangle. I have 2 sides of the right triangle, so really this is reduced to a Pythagorean theorem question. So allow me to clean this up a little bit, and I'll go into more detail what I mean. Okay. Whoa there, Racer. Calm it down. Okay, so allow me to kind of reload what I'm talking about. My diagram's a little bit cleaner. So if I'm looking for this distance, or this coordinate y, excuse me, that's the same as finding that distance off the axis here, which is the same as finding the distance to the x-axis in the middle of the triangle. This is, again, really good news because if I know this is equilateral and the distance between C and B is 2a, that means half that distance would just be a. Likewise, if it's equilateral and the distance between C and B is 2a, so should be the distance between C and a, so that's 2a. So to find this distance, this unknown distance, I'm just going to use the Pythagorean theorem. I have one side, and I could square it. I have an unknown side, which I can solve for in the hypotenuse. So this question mark can be solved by solving this equation. A squared plus question mark squared is equal to 2a squared. Now let's break out our algebra shoes, because that's all this is now. Question mark squared is the same thing as 2a squared minus a squared. Question mark squared is equal to, well, if I have 2a squares and I take one away, that should just be an a squared. So if I take the square root of this side, square root of this side, question mark should be equal to plus or minus a, but of course we're talking distance, so we'll keep the positive. Question mark is a, that distance is a, my answer is a. A little bit tougher problem, a little bit different approach than used to seeing, but certainly one that is definitely solvable. Here, a midpoint question. I love these. A segment has a midpoint at 3, 4, and other endpoint at 2, 3. What is the location of the endpoint? So I'm going to kind of map this out differently, and we're going to use the quickest possible approach, which to me with nice numbers is going to be logic. So I have some endpoint here. It's going to be -2, 3. I have some midpoint over here that's going to be 3, 4. I have to know where this third endpoint is. Well, if I know this is in the middle, then I know it's half the travel distance. So I'm going to ask myself a couple really crucial questions. In terms of x, if I'm going from -2 to +3, how far is that? And hopefully you guys have paused the video and determined it's a +5. So the second part of my travel should be the same. So it's +5 to 3. It should be +5 more, which should give me 8, which tells me more or less that C is the answer. But let's confirm this by doing the same kind of logical thinking about our y values. So 3 to 4 is going to be a distance of +1, so my next jump should be the same. So that should be 5. And again, C was kind of confirmed to be the answer because it's the only one with 8 for an x coordinate. But there you have it. That's going to be 5. Now, alternatively, could you use a midpoint formula? Yeah, absolutely. If you want to see that, post it below, and I'll maybe kind of reshoot part of this video so you guys can see the use of the midpoint formula. Otherwise, this method is good enough for us, and really the methodology is less important. Okay, let's talk 6. Now, 6 was a monster of a problem. It's kind of like the multiple choice one we had just a few seconds ago, where you really have to kind of use your intuition about where these things are placed. So the formula for finding the area of a triangle is 1/2 base times height, where b is the length of the base and h is the height. And what is the area in square units of this triangle? Well, to find the area, I need the base times the height. I have the base. It's actually given to me directly. It's going to be this distance, or I should say indirectly. If I'm starting at 4, ending at 10, that's going to be an overall distance of 6. What I don't know is this value. But again, that value is trapped within a triangle, but furthermore trapped within a right triangle in that triangle. So we're in business. If this distance from here to here is 6, that means half that distance should be 3. 3 from 4 makes that distance 7. Okay. If you look at this distance total, and again that's kind of confirmed here, if you look at this distance this way, well, I would argue that we're starting at the y value of 2, ending at the y value of 12, making question mark a value of 10. So if I have my distance here is 6 and my distance here is 10, that's my base times my height. So the area being 1/2 base times height results in 1/2 6 times 10, direct substitution. Again, 10 is my height. Whoop, there, I overshot it. 6 is my base. So I'm looking at 1/2 times 60, which should just be 30. So looking at A as the answer. All right, well, I really hope this helped. Again, this was homework 1. Hope you're looking through this in preparation of your quiz tomorrow. I'm sorry for the lengthy video, but you know, good things take time. I'm posting the other one as well right after this one. So if you did this homework, you feel good about it, make sure you're moving on to the second homework. Make sure you're pacing yourselves well. Putting the homework on you guys to do all week is really putting, I know, a big strain on your ability to pace yourself, but hopefully you guys are keeping up. This will really help for the quiz you're going to have opening Thursday and running through Sunday, right? So you guys have a good Halloween, have a safe Halloween, and I'll see you guys later.